Hello again, that is Haddad here. So we have just finished 7 points on our first lab. We have configured OSPF on router 1 and we have configured OSPF on router 2. We have checked if they form neighborship and we've seen that they did. And also we have talked about the router ID. Now we need to continue the lab and we have to finish it. Point number 8, enable OSPF on router 3 and assign it a router ID of 3.3.3.3, then advertise all connected interfaces to OSPF. So the same as we have done in the other 2 points. This is now router 3. We have to enable OSPF on it. We have to give it a router ID 3.3.3.3, and then we have to advertise the connected network. Okay, these are the connected network that we can see it over here. This is a connected network, and also this one is a connected network. So we need to advertise those 2 networks inside OSPF for router 3. Let's go directly to router 3. And from here, we go to routing, and then we go to OSPF. I need to put the router ID, so I have to go inside instances. And then from here, I will put router ID 3.3.3.3. And then I will go to networks. From here, I have to advertise the connected networks. 3.3.3.0/24 inside the backbone area, and 192.168.23.0/24 inside the backbone area. I would directly click on neighbors. It has directly formed neighborship with the router 2, and then inside LSA, you can see here there's just exchange LSAs, and now router 3 is able to reach 1.1.1.1. It's really nice how OSPF can work directly. Okay, and then from here inside the route, now router 3, the routes that he has learned from OSPF, he now know how to reach, for example, the network 1.1.1.0, which is the network connected to router 1. Okay, let's see what we have to do more. So step number 8 is done. 9. Check if router 2 and router 3 has formed adjacency on OSPF. We have seen it, yes. And then ping from router 1 to 3.3.3.3. Do you have a reply? Before I do that, I just want to go to router 2 again and to routing OSPF and to look inside the neighbor here. As you can see, router 2 has formed neighbors with 1.1.1.1, which is router 1, and 3.3.3.3, which is router 3. You can see because we set the router ID manually, so he can see them here. Okay, and he is the router is connected to router 1 and is connected to router 3. That's why he can see both routers. Okay, so they ask us if we go to router 1. Let's go to router 1 now, and if we can now ping 3.3.3.3. Let's see. Ping 3.3.3.3. We have checked previously that we couldn't ping 3.3.3.3 from router 1 because there were no route. I would say here source address 1.1.1.1. What I'm saying here, if I want to open again here the picture, I'm saying to the router 1 that I want to ping this network. So I want to ping 3.3.3.3, this interface on router 3, but I want it to come from your source, from the source address 1.1.1.1. That means from the loopback interface here, or the bridge interface. So again, I'm saying to router 1, you have to ping for me the loopback interface of router 3, but the ping has to come from this source address, which is 1.1.1.1. Okay? And this way we can know that 1.1.1.1 can reach 3.3.3.3. Okay? Let's see. If I do the ping now, and we can see that we have a reply. That means that OSPF is working for us, and we can see that there is a route from router 1 to router 2 to router 3 to all networks which are connected to those 3 routers. If we want to do another test, what we can do, we can go to tools, and from here I can go, for example, to telnet, and I will make a telnet from router 1 to 3.3.3.3. Okay, I'm telnetting from router 1 to 3.3.3.3. And then when I say telnet, you can see directly, will ask me for the username and password. And I'm now in router 3. If you want to be more sure, we can say export. Okay, and here it will give me the configuration which are on 3.3.3.3, which is, for example, the router ID that we have put on OSPF. We can see here the IP address on Ethernet 3, okay, and here the configuration also for the OSPF on router 3, okay. The last thing that we need to check here is the routing that we have learned from OSPF, okay. To do that, we can go to IP and then to routes. You can see here, those are the routes which are inside the routing table of router 1. You can see that we have here the DAO. That means dynamic active OSPF. That means that's the route that router 1 has learned from OSPF. Okay? That means that router 1 has learned how to reach 3.3.3.0, which is the network connected to router 3 from OSPF. And it's saying that to reach this network, I need to send my packet to 192.168.12.2, which is the IP address of router 2 Ethernet 1, which is connected to router 1. Okay, and of course here it would give the administrative distance of it. Yeah, by the way, this is the administrative distance, the default one of OSPF 110. Also, he has learned from OSPF the network 192.168.23.0/24, and that's the network between router 2 and router 3. If we look here, there is let me just take a bit here. There is the network 192.168.23.0, and the router 1 has learned from OSPF how to reach also to this network. That means he can ping now this interface or reach this interface and this interface. Okay, the same on the other routers also. If we go to router 2, for instance, and then we go to IP, and then we go routes. Also, we can see that he has learned from OSPF to reach 1.1.1.0 and 3.3.3.0. And if we go to router 3, let me close this, and then we go to IP routes. That's the routing table of router 3. And then we see that he has learned how to reach 192.168.12.0. That's the network connected between router 1 and router 2. And 1.1.1.0, that's the bridge interface that we have created on router 1. So let's check now if we have more steps to do. Step number 10, ping from router 1 to 3.3.3.3. Do you have a reply? And we have seen that we do have a reply. This is the whole lab that we had to do for configuring OSPF on a single area. I hope you enjoyed it, and I see you in the upcoming lecture.